Yes, welcome to the course Fundamental of Physics, GES 132. And this is your book as you see, and I am your instructor. My name is Shafiq Anwar, and I have already made a YouTube channel for you to help you gentlemen, and you can subscribe it and like it and comment always and press the bell icon so that whenever I upload new video you will be informed of that video inshallah. Now we are using the blackboard technology also, as you know, and we will upload all the material you need on this platform. So let's come to the point. We are going to start from the chapter number 2, which is motion in one dimension. The motion of the object when it is traveling along a single line, whether it is along x-axis or y-axis. So motion of an object of anybody along one single line, it may be straight, it may be curved. Sometimes you are taking turn in your car, so still it is one-dimensional motion. What we will be studying in this chapter: the position, displacement, distance, the velocity. What is the difference between the velocity and the speed if you are given the initial or the starting position and the final position and the time, initial and final. Then how to interpret a graph between position and the time. We will be explaining one by one in detail. So how to define and distinguish between the average acceleration and instantaneous acceleration. And there is another second type of graph. First we have between position and time, then we have between velocity and time. Here we get velocity average, here we get acceleration average. So we will explain. Then we will discuss 3 equations of motion we'll be using for one-dimensional motion x or y-axis, and then we have to use some the problems, methods, how to solve the motion problems of different objects. And then we will be using the same equation of motion with a little change for the vertical motion. This is the free fall motion we will be explaining in detail. And then we will calculate the position and velocity of the objects in free fall motion. Whenever we are studying the motion of different objects, we distribute them into branches. The first branch is called the dynamics, the study of the motion of the objects, in when with regard to its causes, right? So when we use the forces or the masses, we call this branch dynamics. So the study of the motion of the objects with regard to its causes. For example, the masses, when you hang some masses with the object or you apply the forces on some objects, this is the cause of the motion of different objects. We will be studying this in dynamic. All right. Now, you study chapter number 4, right? And then we have, the second branch which we will be studying, and that is the kinematics. So the study of the motion of the objects without regard to its causes. We don't discuss the masses and the forces. What we study instead, we discuss the distance, how much displacement between initial and final point, and what is the initial velocity and the final, how much time you take from displacing an object from one point to the other, and what is the acceleration. We will study all these things in chapter number 2 and 3. Now, displacement, as you see, displacement. So this and this is placement. For example, I am at this place, I am changing my position, so I am at new position now. That is initial x sub I we use, x sub I, and the final position f for final, so x f, right? So this is final, this is initial. And what is the rule? Always final position minus initial position. Keep in mind, this is the basic rule to find the displacement between the two positions for an object. For example, if you see this crocodile, it's here at the x I, for example, 20 meter, x final, for example, 80. So final is 80 minus 20 is equal to 60. For example, you will get its displacement, and the unit is meter. So the displacement may be positive, may be negative. It depends on initial and final position. For example, I have all these examples on the left side. The displacement will become positive if you calculate it. All these examples on the right side, you will get the negative displacement, mean it will be towards the negative x-axis, because you know you use right side plus x and left side minus x. Similarly, you use plus y up and minus y down. Alright, if you look here, this is initial position. It goes to the final position here, right? 80 is the final, initial is this one, 10. So final 80 minus initial, which is 10. So you get plus 70. That's why it is along the positive positive x-axis. So this is positive displacement. As I told you, all these you can do it by yourself, and you will find that all these will become positive displacement. This side, for example, you start your motion from this point 80. 80 is the initial, and you reach at final, which is 20. So final minus initial always. So final is 20 minus initial is 80. So you get minus 60. Minus 60 centimeter is the magnitude, is the value of the displacement, and negative sign shows that it is along the negative x direction. So all these will become, you know, the negative. Keep in mind that distance traveled versus magnitude of the displacement, these are two different things. For example, if you start from this point A and you are moving like this, this is B point, and if you keep on measuring the distance, and you will get the total distance. But instead, if you go for the displacement, this is the displacement, because the displacement is equal to final minus initial. This is displacement, and the distance, you see, if you calculate from here to here direct, it will be of course less than this one, right? So keep in mind the magnitude or the value of the displacement if you measure it directly. Keep in mind the displacement is always a directed distance, mean distance in a direction from the first directly to the second, and you subtract final position minus initial. Always keep in mind, please. And the distance you can keep on measuring, so keep in mind the difference. So this is the misconception alert, as I told you. Yes. Now, next topic we are going to discuss is, this is another example. For example, if you have a cyclist, he rides from west, okay? A cyclist rides 3 kilometers west. We have these directions: east, west, north, and south. All right? And he rides 3 kilometers west. West is this side. So he starts from here, and west, this is 3 kilometers. Right? This is 3 kilometers. And then turns around and rides 2 kilometers east. He turns around, and this side is east, you see. So he starts from here and then this side, so this is 2 kilometers. What is her displacement? You see, this is final position, this is initial position. So always from initial to final, right? So you will get this one here, you see, final 2, right? 2 kilometer final here, 2 minus initial, this is 3 kilometer, right? So minus 3 is equal to minus 1 kilometer. 1 kilometer is the magnitude, is the value of this displacement, and negative sign shows that it is towards this side, because I told you that displacement is always from the initial to the final position, and we write it final position minus initial. Keep in mind, this is the basic rule, so you have to keep in mind. Okay, as you see here, that displacement is negative because we take east to be positive. This is east positive, and west we take negative x-axis. Okay. Now, the second part, you have to find out the distance traveled. The distance traveled is, you see, start from here up to here. How much? 3. Then add this up to here, 2. So 3 part plus 2. Distance you simply add up. Positive. Distance is always positive. Height is always positive. For example, if I have this room, so I would not say the height of this room is minus 2 meter. Simply 2 meter. Okay? Height is the distance. And the magnitude of the displacement, as I told you earlier, that it is 1 kilometer. Negative is for the direction only. Okay? This was another example. Right. Average acceleration then. Now, average velocity is the total displacement. Displacement, you remember we did before, it's delta x is the displacement, which is final position minus initial position. X we use for position, I for initial, F for final, divided by delta t, difference in time. This is different in position, which is the displacement, and this is difference in time, final time, right? For example, if a person is here at time t is equal to t initial is equal to, I say, okay, 5 seconds. He is at x initial is equal to 2 meter, and then he travels up to here. For example, final position is 4 meter, and this is, I say, okay, this is final time 6 seconds. So I would use here a final position 4 minus initial 2, final time 6 minus 5. So you get 2 over 1, which is 2 meter per second, will be your average velocity. Okay. All right. The unit is meter per second, because this is delta x displacement, its unit is meter, and divided by time, difference, which is the unit of time is seconds. So meter per second, as you see, I wrote it here. All right. Now, what is the difference between the velocity and distance? So velocity is equal to displacement over time interval. Speed is equal to total distance divided by the total time. Okay? Now, you have speedometer in your car. Whenever you are traveling, it is giving you the speed. Speed is a scalar, mean we don't need direction for specifying speed. For velocity, yes, we have direction, like this one. This is plus, so mean it is going to the positive side. Okay, so this is plus, this side negative, so this is plus 2 meter per second, mean 2 meter per second is the magnitude, the value of the velocity, and plus mean it is moving towards the positive x-axis. Speed has no direction, only magnitude. What's magnitude mean? Number and unit. For example, 2 meter per second or kilometer per hour, whatever you like. So keep in mind that speedometer of your car, it tells you simply the speed, not the direction, not the velocity. All right. Now, how we interpret, how we use the graphs, you might have done in math course. When you draw a graph between two quantities, one is x, one is y, you have x and y different points. For example, so you draw it, for example, x is 1, 2, 3, 4, 5, this is 2, 4, 6, 8, 10, like that. The first one is x1, y2, x1, y2, this point. The second one, x is equal to 2, and this is equal to 4. For example, this is 2, 4, 6. So this is 2 here, right? X is 1 and y is 2. This is the first point, then x2, y4, x2, y4. So your point is here. So you draw a graph like this one, okay? And you find the slope. And the slope is equal to delta y over delta x, okay? In this case, we will be having x-axis position, this one position, which is x, and x-axis you have time in seconds, right? So, for example, if you have this time and this position, x, okay? So, this will be in fact the slope, delta x over delta t, final, initial, okay, sorry, time, initial. Right, so this is the same what we just finished in the beginning of this topic. Velocity, average velocity was equal to delta x or delta t, final minus initial position, final minus initial time. So now the average velocity, this will give you in fact the average velocity, AV for average. So average velocity, it will give you the slope. Okay, if you have, you know, a graph like this, this is time in second, this is position x in meter, you have different points. You see, if you take any 2 points, you see, you need 2 points to find the slope. y2 minus y1, x2 minus x1, right? Y-axis. So now you have a position x along y-axis and time along x-axis. So what is the same thing? If you take these 2 points, or these 2 points, you will get the same slope because the slope is the same for all, for this line, straight line. What I do, I prefer the initial and final position, you get the slope. And it will be the same for any of the time along the x-axis. For all times between this and this, you'll be having the same slope. Okay? Even you take these 2 points, these two, whatever you take 2 points, you will get the same slope. Right. Now, if you have this one final minus initial, you will get the positive slope and positive velocity. If you have, for example, a line like this one, you see this is the final position. For example, I say 8 minus initial, again the same position at 8 minus 8, 0. That's right. So 0 divided by whatever you have time, you will get the 0. So 0 velocity means 0 slope. Okay? Then if you have, for example, a line like this one, so you see you are moving like this one. This is initial, this is final. This is final here, position along y-axis. Okay? So this one here, for example, here 2 minus 8. So 2 minus 8. The time, whatever you have, you will get minus 6. For example, if you have 6 minus 3, final minus 3, so this is 3, you will get minus 2 meter per second. So this is negative, you see. Once you are going down, this is negative. This is how you understand and interpret the graph between position x and time t. Okay? Similarly, if you look at this example, if you have any questions, so you can check with me at the end, last 5 minutes, inshallah, and I will explain it, don't worry. This is another example, right? A cyclist is riding, is moving, and first he starts from 0, this is position x, he goes up to 1200 meters. With the passage of time, he is moving. So you see, this, as I told you earlier, this will give you positive slope, mean positive velocity. This is horizontal line, and you know that slope of the horizontal line is always 0. You can check it mathematically, as we already discussed it, that this is the final position, 1200 minus initial, again 1200 divided by time, 1000 minus 600, this is 400, so the same amount, so you will get the 0. Okay, so you have 0 velocity, 0 slope. Okay, 0 velocity mean 0 slope, right? And now again, he is at plus 1200 and distance is decreasing, mean he is moving to the left, to the negative x-axis. Okay, this is positive x, this is negative x. So this is final. Okay, this is final and this is initial. You will get minus, as I told you earlier. So the slope of the line which is coming down, you have negative. So negative slope means negative velocity. Okay, right. Then we have the second type of graph. Before, you have here time, here position x in meter. Now instead of position, you have velocity in the unit of meter per second. Here you have the same time. So if you find the slope, V final, V initial, time final minus time initial, which is delta V over delta T. Okay, before you have average velocity, okay, this will give you average acceleration. Before you have average velocity V, now you have average acceleration slope. Before you have x final minus x initial, now you have final velocity minus initial velocity, and then it is delta V over delta T by the way. So this is what you get. You know, this. All right. Same thing. What I do before: position here, time here. Right. Okay. Now, this is the velocity and okay. Sorry. Okay. Still it is. I'm sorry. I was taking the acceleration, but I will take it again when I discuss with you the basic definition of acceleration. I'm sorry. So that was the velocity. Now, velocity, instantaneous velocity. So you see, this is position x in meter. This is time t. Okay. Now, as we already discussed that whenever you have a straight line, you can find out the slope. But when you don't have the straight line, you cannot find the slope directly. What you can do, you can draw a tangent line, the mass, at a point where the time is given. For example, at time 3 seconds, you want to find out the instantaneous. You see, what does it mean, the instantaneous? Instantaneous velocity means at any instant. At any instant, okay, at any time. This time interval is so small, it's not 0, but it is so small that it is very close to 0. So instantaneous velocity is equal to the average velocity, okay, or the slope of the tangent line at that point. You get the point? If you draw this tangent very clear, what is the tangent? Tangent is a line which touches the curved surface at only one point. Okay? So once you have a good graph in millimeters, for example, so you can take care of. So this is how we can find out. Okay, we will be solving some examples for this example, for this concept. Now, yes, let's do this example to what we already studied, the definition of average velocity and instantaneous velocity. A train is moving and you keep the record of its motion. You note its position, its location at a different time, and you draw the points and join the points, and then you have the graph. Now you have to find out the average velocity for the total trip. You have this graph, straight line, then horizontal, and then this curved. From here up to here, this graph shows the motion of the train at different times. Now, total trip, you start from here up to here. So this blue line is for the total trip. And keep in mind that average velocity, you see, is equal to the slope of this line. As I told you, you can take any 2 points, but it's good to take far away points, initial and final. So this is slope mean delta x over delta t, right? So I can write x final, x initial time. Now, final 10 minus initial 0. This is the position. Time is 12 minus 0. You will get 0.833. this is plus, right? When we don't write anything, it means it's plus, but you can write it if you want. What does it mean? It means it is moving to the positive x-axis. Now, the second part, the average velocity during the first 4 seconds of the motion. First 4 seconds, you see this is time in seconds, up to here. Go up, so this is your line now, from O to A. So you have to find out again what average velocity, keep in mind. Average velocity is again slope of that line, okay, which is delta x over delta t, which is x final minus x initial over time. X final, this is the line. Final is 4 minus initial 0. And time final 4 minus initial 0. You get 1 meter per second. Again, it is positive. So mean it is moving towards the positive x-axis. Then you have C part now. The average velocity during the next 4 seconds. Next 4 seconds mean you already finished up to 4. Now from here up to here. Horizontal line. You can say directly 0 because it's the horizontal line. Okay, but you can calculate it if you want. We average slope of the horizontal line. Final 4 minus initial again 4. Time is 8 minus 4. You get 0. Then instantaneous velocity at t is equal to 2 seconds. 2 seconds here. It's already with this line, right? So we have already calculated, which is 1. Already we calculated in B part, right? So it's 1, because if you ask what is the instantaneous at any instant, so instant is 2 seconds, 3 seconds, 1.5 seconds, it will be the same, because you already finished in part B that V instantaneous will be equal to the average velocity, because this is when you have the straight line, instantaneous is simply the slope. Okay, this is 4 minus 0, 4 minus 0, 1 meter per second, same as B. As part B. Finally, the instantaneous velocity at 9 seconds. 9 seconds is over here. If you go up, you will come here 4.5 meter. Okay, so now you have this tangent. Draw the tangent line here, and it will meet here. This is 3 seconds here. Okay, now you can find out the instantaneous velocity is equal to average velocity, which is the slope, which is slope of the tangent line, right? Okay, I take this one. Final 4.5 minus 0, because x is 0 here, and then 9 minus 3. So you get, in this case, 0.75 meter per second. Okay, so I think this is enough for this lecture. So see you in the next part. Thank you very much and have a nice day.